Hello everyone, welcome to another episode of Fundamentals Friday. So in the video today we're going to be talking about user-defined data types. Now in the last video we talked about data types and tags, and if you didn't catch that video I highly recommend you check it out. So I'm going to put a card up somewhere if it works. I'll also put a link to it in the description. But in that video we talked about creating tags and different types of data types used, and I kind of glossed over user-defined data types. I highlighted the folder and said that we would get to it in a future video, so here's that video. So user-defined data types are very powerful, and so I'm going to show you how to create them and where you can use them. So if you're interested, also this will be a very good tool for you to use in your programming and troubleshooting needs. So if you want to create the same UDT, I highly encourage you to do that. So if you want to check it out, follow along, and I hope you enjoy the video. Alright, so we're back again. Today in this video, just like in the last one, we'll be using the same software and the same PLC as we did in the last video. The software isn't as important. This has been a feature of pretty much every version of Studio and RSLogix 5000. And this is supported on any Compactlogix or Controllogix processor that you'd want to use with Studio 5000. So in this video, just like I said earlier, we're going to make a data type that I find to be very useful in troubleshooting and modification, testing, things like that. So this is going to be a test data type. So we're going to get started. So the first thing I want to do is I'm going to want to go offline. You can make tags online. You can make UDTs online, but it's not really a good idea, especially if you have to make a change at some point, because it changes it throughout the program if you have multiples of this particular data type. So unless you're importing an existing UDT and you already know how it works, I recommend making new UDTs offline. So what is a UDT first off? So a UDT is a series of data types, just like the ones we talked about in the last video. Like, let's say for example you've got bits for booleans, you've got some integers, real numbers, things like that. A UDT is basically just a collection of data types that you find useful in a programming sense. Let's say for example you have like a sensor. You may want to incorporate some kind of filtering for each one of your sensors that you use in the project. So each sensor is going to use the same filter timers and things like that. So that's where you would want to use a UDT, because you can just have one tag for each sensor and it has all of the timer bits, all of the control bits, that you may want to use for each sensor, and it's copied every time you use that tag. So, and it's just one tag and it gives you everything. So that's the benefit, the beauty of using a UDT. So that's what we're going to be going through today. So let's go ahead and get started. So in order to make a data type, you have to go into your data types folder, and I kind of described this in the last video, but real quick review again. So sometimes when you open up Studio 5000 for the first time, this assets folder sometimes is closed. So you just open it, and in that folder you'll have one folder called data types, and that may be collapsed as well. You just open it and you'll see a series of other folders. So in this we'll be using user defined. So in order to create one, and just to show you, I've already got a few that I've made in the past, but in this video we'll make a new one. So when you want to create a new data type, you right click on the folder and you'll have two options. You have new data type, which is the one we use today to create one, or you could import. So if you have a data type like this test one that we'll create today, and you like it, you want to use it in other programs, you can import it into any program, and you can subsequently export it when you finish. And we'll go through that real quick too to demonstrate how to do that. But in this video, first we will do the new data type. So you'll come up to this new window, and you'll have a few different things, and we'll go over real quick what these are. So this name is the name of the data type. So when you go to add a data type in the control tags library, like we discussed in the last video, that would be this name. So where you had like bool or dint, for example, whatever you put in this name is going to be that name. And so when you go to use the tag, that's all you have to type in, and that'll show up in the list once it's incorporated in the program. You don't have to be very specific, but it's always wise to give a name that makes sense to what the tag is. So as I said, we're going to be using a test tag, so I'm going to be calling this test bits. So the next part you have is the description. So just like in the last video, we talked about the description not being all that critical. But what I like to do with my descriptions for UDTs is I like to give the date it was made, and I also like to provide a revision code. You can do it however you wish to do it, but this is just my personal process. So I give it a name, test bits, UDT, and today's date is April 9th, 2020. So we'll add that real quick, and the revision. So this is revision 1.0. So you can make the comment or the description whatever you want it to be. I just find this to be very useful, so that as you build the UDT up, or maybe you make changes over the years, you can keep track of which is the newest, which is the oldest. So you may end up having multiple different programs with different versions of the same UDT. That way you don't get mixed up, and if you choose to update it in the future, okay, well, that modification won't exist in older versions. So you have the older version, but you also have the newer versions that you create, whatever works for you. So the next part is this members box. So the members are the tags that you're going to associate with this UDT. So it also has a name, and these will be the name of the individual tags within the UDT. And each of those is going to have its own data type, and these will be data types that either already exist. So you can't make like a UDT within a UDT, but you can incorporate an existing UDT into a new one. So any data type that already exists up to this point can be added to the data type. So you just define a name, a data type, and a description for each one of the tags. You'll also notice this data type size. It's very important to know how large the data type you create is, because each data type consists of a certain amount of memory space. And the more you have, obviously, the larger the size is going to be. So just keep in mind that the larger the data type you make, it may not be as usable on other processors if they've got reduced memory capacity. So just keep that in mind. But as you notice, it shows question marks. Until you apply the UDT, you will not see this populated with this size. But once we apply this UDT, you'll see that number show up there, and I'll show that to you when we get to that point. So in this, I want to have a couple different things for the test bits UDT. So one thing that I like to use is Boolean bits. Now there's many different ways you could incorporate Booleans, but As we described the use of dents in the last video, a dent is made up of 32 bits, and you can use each individual bit within that UDT, or within that data type, excuse me, as an individual bool. So to reduce the size and to make it more efficient, that's what we'll do. So we'll consider this to be the bool bits. So we'll call the name bool to make it easy on us in the future. So it'll be bool. Now the data type, as I said, it's going to be a dent. But I don't want to just have 32. I may need more than that in the future. So one thing you can do is create an array. And all an array is just saying that I want this dent, but I want it, let's say, 4 times. So in order to make an array out of a tag, you do an open bracket and then the number of tags or data types you want associated with this. Let's do 4 in this case. So what that's going to do is it's going to create 4 dents in an array. So there will actually be 4 individual dents associated with bool, which gives us 32 times 4 total number of tags. And make sure that once you do that, you close the bracket. So we'll do that, and then index over, and we'll add a description. So test bits. All right. So, and we can add as many tags as we want in this UDT. So as you create a new one, you'll have an empty field show up underneath. It works just like the tag database in the previous video that we discussed. So the next one I want to add is pointers. Pointers can be very useful for marking where you are in the program. Now in Studio 5000 and in other programming software, you have over here what are known as bookmarks, where you can mark areas of the logic, but they can only typically mark the actual rung itself. But sometimes I want to be able to go back to a specific element in the program. So I like to have pointers in my test bits to be able to go back to whatever the tag is. So all I have to do then is cross-reference the tag, and I'll show you that in a little bit. So I'm going to add pointers. So we'll do pointers, and we'll do it the exact same way. I'll give it a dent, and I'll give it 4 as well. So alright, so we have pointers. So what's another thing you may want to use? Well, anything you feel like would be necessary or could be useful in the future for testing purposes. So sometimes I may want to hold a number in memory that's not going to go anywhere in the program. It's just something I want to do, like a freeze frame of a value that changes in the program. So I'm going to give myself a few number tags so that I can load a number into it. Now I could just use the whole dent of one of the bools, but it kind of gets confusing when you go to look at it. So I'm going to actually give myself a dent register, and I'm going to give myself some dents, but I'm going to make an array like I did with the bool tags. But this one I'm going to give myself 8, so I have enough to do tests with. Okay, and we'll also give ourselves some real numbers. So we'll do real, and just like with the dents, you can do an array of these. So I'll give myself 8 real numbers, and you can give yourself more or less, whatever you feel is necessary, or however many you want for your specific test UDT. So keep going. Alright, so now we have numbers, we have bits for binary stuff, and now what else could we use? Well, sometimes I feel like timers can be useful. So while you could create a custom timer, you know, if you're planning to use it in the actual program, then you would make a custom tag just for that. But let's say you just want to test out something, you may want a custom timer for it, just to throw it in there and test it, whatever the case may be. So we'll give ourselves a timer. And same thing, timer, and I'll give myself 8 timers. Okay, test bits, timers, and one more, I'm going to give myself counters. Same thing, you know, that way you can do timers and counters, whatever you need to do. So we'll do that, counter, and we'll call it, oh, forgot one thing. We're going to do 8 of those. And test counters. Alright. So this is all I'm going to give myself for this test data type. You may feel that more tags or less tags may be necessary for your test tag. Whatever works for you. But in my case, this is most of what I use typically. As I said, you know, you may come across situations where you may want to add more stuff to it in the future. You can easily edit existing UDTs in the, you know, as time goes on, and whatever works for you. So, but like I said, this was all I'm going to add for this one. So I'm going to click the apply. So as soon as I hit apply, you see that our data type size increased. Now it says that it's 288 bytes of data to make this UDT. So every time we use it, that is utilizing 288 bits or bytes of memory with each instance of the tag. So if you have a very large UDT, keep that in mind because it can eat away at your processor's overall memory capacity. But in this case, that's a very small number. This processor can actually handle, let's see. If we go into our capacity, we see that we've got plenty of bytes available. So we've got more than enough to spare for this tag, but just keep that in mind. And your particular situation is going to vary. You're going to want to look at your processor's capacity before you use very large UDTs. But like I said, in my case, it's not going to be an issue. So when we're done with the UDT, when we hit apply, it's created the UDT, and you'll find it over here in the file that we've got for the UDTs. So we could just close out, or if you didn't want to, you could hit OK and it would just close that. So now that we've made the UDT, I want to use it. So in order to make one, or in order to use it, we go into edit tags just like we did in the last video. So when I make a test bit tag, I like to give my name to it. So test, we're indicating that it's a test tag, and I'm going to put my name there. Okay. And in the data type, we say that we're using test bits, and you can just type it in instead of trying to find it in the list. It's a little faster that way. So if it exists, it'll populate immediately as the letters come together to make that word. So and then we'll give it a description. Okay, and you can give it whatever description you want, but that's what I'm going to do. All right. One other thing, now that we've made this change and we've added this UDT, I'm going to download this, and we're going to go online with the processor, and I'll show you where you can use the UDT in a practical situation. So we'll go and download this right now. Okay. So let's go back to the logic. So as you can see, we're online now. Alright, so I want to use some of those data bits that we've created. So let's say I want to stop this strobe bit from running. So we'll add a test bit. Just like in the last video, if you want to go into edit, you can either double click here, use the hotkeys Control-Shift-S, or you could also hit enter if your mouse is already on this block here. So we're going to start and add a contact here. So rather than hitting new tag, we'll just double click, and you can go ahead and start typing it if you want, because if it exists, it'll automatically populate with the characters. Alright, now for this, we're going to be using a bool. So I can go ahead and start typing. One thing you'll notice, if you remember in the last video I spoke about how standard tags cannot have periods. That's not entirely true. Data types like this, if the tag within it can have a period. So if I'm saying that I'm using the bool tags of this data type, that's going to have a period. But if I wanted to create a new tag name, I can't use periods in it, because periods are indications of basically going to the next level of that tag. So the main tag would be test eTaylor, and then a branch down in that tag is .bool. Then, because there's 4 dents, we have to tell the controller that we want to use one of those 4 dents. So the next notation is we'll use 0 because it's the first one, but that can go all the way up to 3 because we have 4 in there. So it would be 0, 1, 2, or 3. And then we need to tell it what bit within that dent we want to use. So we haven't used it, so I can just say .0. But if you didn't know which tags are available, you can open the tag and do this little drop down. If you've got any bools used, these will be pre-selected. So if there's anywhere in the program where you're using a test bit, you'll see one of these highlighted. But in our case, we'll be using the 0, and you just close out of it. So now we have a test bit involved in the program. Now, it gives you a description which is based off of the description we already gave it in the UDT creation application. But when using test bits, I like to give a description as to why I've got a test bit used in the program. So alright, and we'll give it a date. So if I come back a few months from now and I want to know why I'm not getting a strobe bit, I can find this tag and I know when I put it in. So we'll put a date. Now what this allows me to do is I can toggle this bit because it's not being controlled in the logic. I can enable it, I can disable it. I can maybe even make a whole new branch of logic and disable the original and start a new one. Whatever the case may be, whatever works in your situation. So in order to toggle the bit, if you didn't already know, there's a hotkey for that. You can right click and do toggle bit, but the easy way is to do Control T, which allows you to force the bit into one of the two states it's in. So toggle on or toggle off. You just hit the same button, just Control T every time, and it'll just go to whatever the next state is. So we will finalize this. Alright. So as you can see, because the bit's not active, the strobe has stopped. But if I want to start it again, like I said, Control T, and now the timer is going again. So you can see kind of how you would want to, or where you would be able to use this in a real project. You know, if you are commissioning a new piece of equipment, maybe you've got sensors missing or whatever, the use of the test bits allows you to troubleshoot issues and make changes on the fly without creating whole new tags, and just test out an idea. And if it doesn't work, you can go back to the original. So that's very useful in a practical programming environment. So as I was mentioning earlier, you have some of our bits that we gave ourselves were pointers. So I'll just demonstrate that real quick for those who maybe haven't seen that before. I'll put one over here in the IO verification. In a future video I'll explain what IO verification is for, but in this video, just for the sake of demonstration, I'm going to add a pointer bit. So again, I'm going to go into edit, and I'm going to give myself a little bit of a branch. And the reason I do it this way is that as a test bit, you can toggle it. So even though it's a pointer, the processor doesn't know that. We're using it that way, but you could technically use it as whatever you wanted. So one way I like to do pointers is use this shorted branch. This way it doesn't affect how the program works. It doesn't affect the logic. It just gives you a pointer, a marker that you can come back to in the future. So we'll add that real quick. Test. And we're going to use pointers. Again, you can just keep typing and it'll populate with the characters that match. So we'll use this first one and .0. Alright, and we'll give it a pointer name. So you may use a pointer in the sense like maybe you've made a change to a value in memory, like maybe a timer value or something, or you made a change to the logic. It's somewhat permanent, but you still want to be able to come back to where you made the change, and you just give yourself a little note. That's really all that a pointer gives you. Just a way to go back somewhere you can put information. You know, like if I made a change to these values, I could put the original value in the comment of this tag, and then I can come back to it and see, okay, well, I don't like that setting, so I'll change it back to what it was before. Whatever the case may be. So we'll finalize this. And just to demonstrate, like I said, because it's shorted, it can't do anything to the program. So I could toggle this all day long and it won't do anything to the program. Now if I actually had interrupted the logic, then yes, I could do that. But because it's just a pointer, I don't want to make changes to how the logic is working. I just want to make it, I just wanted to keep this location available for coming back to in the future. So we'll go back to where we were. So let's say we wanted to go back to that pointer. So one thing that is very useful is what's known as cross-referencing. And all that cross-referencing is allows you to go back and find a particular thing in memory and look for all instances of that. So to enter into the cross-reference screen, you can hit Control E on the keyboard and it brings you to that. Also, you could right-click on a tag and it should have View Cross-Reference as one of the options at the top. But in our case, I like to use the hotkey, so that would be Control E, and we need to search the name. So we know that we're using test bits. Alright, it populates with the name. So if I just leave it this way, it'll find every single tag that exists using test bits. So we hit refresh. I only have 2 because that's the only ones we made, but you'll see the pointer that we created earlier. And it also shows the test bit, the bool that we used. So now I can find any of them in the program and go right to them. And if I want to go to it, all I do is double click on the selection and it takes us right to where the pointer is. So you can kind of get a sense for how that could be useful. So if you made many changes in a much larger program, you know, having pointers like this easily accessible makes the process of troubleshooting so much more fluid and easy to do. So, you know, and like I said, this is a simple example, but the same is true regardless of the size of the program. So, and I can find the tag where we have the bit that we were using. Also, if you want to go back to the cross-reference or any other part of the program, you can easily jump back to that screen by hitting Control-Tab. And if you hold that, you'll see things that we already have open, like controller tags and the I/O verification routine and things like that. You can jump back and in and out of specific screens with ease. So that's also another clever little trick if you were interested. Makes shifting through different screens in the program very easy to do. Alright, so you know, you can imagine if we had like hundreds of tags throughout the program, we can easily jump to any of them. We just search for them in this cross-reference and then go right to it. So it's a very powerful tool. You know, like I said, you don't have to use it, but it makes it a whole lot easier if you do. So now that we know how to make a UDT and how you could use it in a practical scenario, as I described, once you've created a UDT, maybe you want to use it in future programs, or you just want to make it accessible so that you can use it wherever. So once you have a UDT that you like and you want to use it again, all we have to do is export. And what export allows me to do is it allows me to save elements of the logic that I create. Now, because we gave it a revision and everything, that shows up in the text. So that's very useful. So when you go to look for it in a future, you can easily see the description that Windows gives it. So when you export objects like this, it saves it as an L5X. And just so you know, or a little fun fact, an L5X can be seen regardless of what software version you're using as far as RS Logix. As long as the elements within that object exist in all versions that you use, you can easily import it without a problem. So you give it a file name just like you would normally and then hit export. So let's say I wanted to import a UDT. So in order to do that, you right click on user defined and hit import. Let's say I had an existing program and I wanted to incorporate the test bits. Even if the program is still currently online, if the UDT already exists, then you can change that. You can add in UDTs as you see fit. So in order to do that, like I said, just go into import and then select the UDT that you want to incorporate into the logic. So here's that test bits one. It already exists, so I'm not going to do that, but you could incorporate that if it didn't already exist in this program. And then once it's incorporated, you can then make tags that use it and go right forward with it. So I hope you guys enjoyed that video. If there's any other particular parts that you want to learn about, please leave a comment down below if there's something you'd like me to do a video on in the future. So I hope you found that informative. Let me know if you guys like that UDT and maybe you want to use it in your own programs instead of creating your own. If there's interest, I will put the tag on, or the L5X file on something like GitHub so that other people can download it if you'd rather not make your own. But you'll find in future videos we're going to be using UDTs quite often. So I felt that making a fundamentals video talking about how to make UDTs was something that was very beneficial to everyone. I can honestly say that once I learned about UDTs, that it completely changed the game for me. It's like it opened up so many doors for writing new programs and making more advanced logic, because I can think of so many situations where I wanted specific tags, I wanted more tags than I had, or it was the same logic over and over again. And having UDT would have completely changed the game. It would have made the process of making all those tags so much more user-friendly, a lot easier to do. So definitely, I kind of wish I had known about them a lot sooner. And now that I do, it's like it's completely opened up doors. So I hope that was informative and an educational video for you guys. Like I said, if you like it, be sure to like the video and comment if you have any suggestions for future videos. And if you want to see more videos like this in the future, please be sure to subscribe, hit the bell icon, and yeah, come check out more videos. I've got more coming, more plans for more videos in the future, and we'll see where it goes. So anyway, like I said, like, share, subscribe, and I'll see you in the next video. Thank you.